Out here, elephants are doing what they do best, eating all day long and producing a surprising kind of raw material.
That raw material is elephant dung, and today we're following it on a very unexpected journey.
What starts as waste will end up as something you could write your next idea on.
Inside this factory, poop is turned into clean, beautiful paper and finished products.
You'd never guess that this textured sheet once smelled like a barnyard.
Around the world, people already use these papers as journals, greeting cards, and gift boxes.
They look like artisanal handmade stationery because that's exactly what they are.
But behind this quiet building is a very unusual manufacturing line.
Today, we'll follow the process step by step, from the dung pile to the finished product. We'll see how the dung is collected, washed, cooked, pulped, formed into sheets, and crafted into everyday items.
It all starts with what elephants eat, mostly grasses, leaves, and plant stalks packed with tough fibers.
Their stomachs don't fully digest those fibers, and that's exactly why this dung is so useful for paper.
Instead of cutting down trees, this factory turns a constant stream of waste into a renewable paper source.
By the end, thousands of sheets roll out of here every week, ready for export and local markets. Let's step inside the Elephant Dung Factory and see how waste becomes something worth writing on.
The supply chain starts right where the elephants live, often at sanctuaries or conservation centers.
Staff and factory workers coordinate to collect dung at regular intervals during the day.
Protection is essential, so workers suit up with gloves, boots, and masks before they get close.
Fresh piles are shoveled into large bins that will be transported to the factory.
Each batch is labeled with date and source, helping track quality and consistency.
Once loaded, the dung makes a short journey by truck from the sanctuary to the processing plant.
The closer the factory is to the elephants, the lower the transport cost and emissions.
On arrival, every load passes a simple reception check before it goes inside.
Deliveries are recorded, and bins are scanned into a basic tracking system.
The unloading zone is designed so it can be hosed down and sanitized after each batch. Still fresh and moist, the dung is opened up and visually checked before processing. Anything unusual, plastic, stones, or trash is removed before the dung goes any further.
What they really want here is the fibrous content, not the wet sludge.
Speed matters. A small facility can handle hundreds of kilos of dung every day. Once sorted, the dung heads to its first big transformation, an intense wash.
The washing section is where this material starts to look less like dung and more like raw fiber.
Fresh piles are submerged in water to loosen dirt, sand, and soluble waste.
As the clumps break apart, the lighter fibers rise and the heavier particles sink. Mechanical stirrers or manual paddles help the fibers separate without being damaged.
The first wash is always the dirtiest, flushing away most of the soluble waste.
Fibers are collected in mesh baskets, which let the dirty water drain away. Wastewater isn't simply dumped. It is channeled into basic treatment systems to settle solids.
Multiple rinse cycles gradually remove odor and any remaining debris.
After rinsing, the material looks less like dung and more like grass clippings or straw.
But before anyone could call this paper safe, it needs a high-temperature sterilizing cook.
Here, hot steam or gas burners heat big cooking tanks to near boiling temperatures.
Loads of clean fibers are added and submerged in water for a long, controlled cook.
Cooking at close to 100 degrees Celsius kills bacteria and softens the plant material.
A mild alkaline agent is often added to help break down lignin and remove any lingering smell.
Depending on the recipe, this step can take 2 to 4 hours for thorough sterilization. While the fibers cook, the Caucasian production team prepares for the next shift of processing.
Safety gear is critical here, protecting against hot steam and splashes.
Clear signage reminds everyone to stay protected around heat and chemicals.
When cooking is done, the vats are vented and opened with caution.
The result is a pale, sterile mass of softened fibers ready to become pulp.
Excess water drains away, while the fibers cool enough to handle safely.
Every drop that comes out here reduces energy needed in later drying stages.
Now this cleaned and sterilized material moves to the heart of papermaking, the pulping room. Here, elephant dung fiber meets water and machinery to become a smooth, consistent slurry.
This is where we really start to see the transition from raw waste to something usable.
Industrial pulpers gently shred the fibers and mix them with water to form a uniform pulp.
The ratio of water to fiber is carefully controlled to keep the pulp workable, but not too thin.
Each batch is fed into the pulper, then flooded with fresh water to begin mixing.
Rotating blades break the fibers into smaller lengths while suspending them evenly.
Operators can tweak speed and mixing time to match fiber type and desired paper texture.
Running multiple pulpers at once keeps a continuous flow of pulp feeding the paper line.
A simple visual check shows whether the pulp is too chunky or too watery.
When you see fibers floating evenly in a milky slurry, you know the mix is about right. By changing fiber length, they can produce rough, handmade textures or smoother writing surfaces.
Sometimes, other natural fibers are blended in to adjust strength or feel.
Eco-friendly binders can help the final sheets hold together and resist tearing.
This is also where coloring begins, with natural or non-toxic pigments added to the mix.
Within minutes, the color spreads through the fibers, tinting the entire batch.
Workers match these colors against guides to keep each batch consistent.
A small in-house lab tests new pigment recipes and checks how they dry on real paper.
Mini test sheets reveal how the color, thickness, and fiber distribution will look when finished. Drying often lightens the color, so adjustments happen here before full-scale production. Once it passes these checks, the pulp is transferred to holding tanks that feed the sheet-forming line.
Inline filters catch any stubborn clumps or stray particles to keep sheets smooth.
At this point,
It's hard to believe the starting material was elephant dung.
Now the handcraft begins, as this pulp gets turned into individual sheets of paper.
Simple wooden frames with mesh screens act as the molds for each sheet.
Each dip collects a thin layer of fibers, evenly spread by the water. As the water drains away, the fibers lock together, forming the basis of a paper sheet. With practice, workers build a quick, almost hypnotic rhythm to keep production flowing.
A gentle shake helps level the pulp and prevents thick or thin spots.
Then, with a smooth flip, the wet sheet is transferred to a cloth to rest. Sheet after sheet, stacks build up, each one slightly different thanks to the handmade process.
Labels track color, weight, and batch, linking each sheet back to its original pulp mix.
Not all paper here is plain. Different vats run with different colors and recipes.
Some batches keep a natural look, highlighting the plant fibers inside. For decorative paper, dried flower petals or leaves are added directly into the mix. As the water drains, these inclusions become permanent design features.
Some screens use patterns or watermarks to emboss textures and logos into the sheets.
The pattern presses into the pulp, leaving a raised or recessed design once dry.
By controlling the tools, one factory can offer a surprising variety of surfaces. Thickness is controlled by how deep and how long the frames stay in the pulp.
Thinner sheets suit letter paper and envelopes, while heavier ones become covers or boxes.
Before drying, wet stacks are pressed to remove excess water and flatten the sheets.
Alignment is important, so edges stay even and sheets don't shift under pressure.
Hydraulic pressure squeezes out trapped water and helps the fibers bond more tightly. You can see just how much moisture is hidden inside each stack. The press holds at a set pressure for several minutes, then slowly releases.
What comes out is still damp, but lighter and much easier to dry.
Workers gently peel apart the compressed stack, so each sheet can dry on its own.
This step requires patience, too rough, and the soft sheets can tear.
Damp sheets are hung or laid out in temperature-controlled rooms to air dry.
Gentle airflow speeds up drying without warping the delicate paper.
Fully dried, the paper is surprisingly strong despite its unusual origins.
Once dry, sheets are collected, sorted by color and thickness, and prepared for finishing. Simple tricks like edge tapping keep the stacks neat and easy to handle.
A slightly uneven edge is considered part of the charm of handmade paper.
Customers can choose from a catalogue of textures, weights, and colours for their products.
Next, these sheets are cut down to the exact sizes needed for different products.
Standard sizes like A4 and postcards are programmed into modern cutters.
Stacks are tightly clamped, then sliced cleanly with a heavy blade.
The cut reveals the dense tangle of fibers that give this paper its strength.
Each edge is a cross-section of elephant-powered recycling.
Smaller tools handle custom orders like tags, bookmarks, or decorative cards.
Die-cut presses punch out precise shapes for craft projects and gift decorations.
Some of the paper becomes notebooks, with dung paper covers and sometimes dung paper pages.
Covers are scored and folded to give clean, sharp bends around the spine.
Stacks of pages are nested inside, then everything is bound together.
Thread binding creates a durable spine without relying too heavily on synthetic glues.
The stitching is both structural and decorative, visible along the edge.
Other designs use glue binding, clamping the pages while adhesive cures.
Even coverage ensures pages stay firmly in place, even with daily use.
Freshly bound notebooks rest while bindings fully set.
Thicker sheets are folded into rigid gift boxes and packaging.
Corners are reinforced with glue and pressure, forming clean, straight edges.
Even as a box, the paper retains its organic, handcrafted look.
Greeting cards and envelopes are also cut, folded, and paired by hand.
By this point, it's hard to believe all of this was once a pile of elephant waste.
Screen printing is gentle enough for handmade paper, yet allows sharp images.
Ink is pulled across the screen, passing only through the open design areas. When the screen lifts, a clean design appears, bonded to the textured surface.
Printed items dry on racks to prevent smudging and to let the ink cure fully.
Every box is counted, checked, and matched to a customer's purchase order.
Barcodes or QR codes help track shipments across long distances. Sealed cartons stack on pallets, ready for transport to warehouses and shops.
From here, elephant dung paper products travel across cities and sometimes across oceans.
Paperwork confirms each shipment, ensuring customers get exactly what they ordered. What started as local waste now moves out into global supply chains. Some factories export to eco-shops, zoos, and museums all over the world.
By the time you see it, it's just another cool product with a surprising backstory.
Each stack is visually inspected for tears, holes, and large impurities. Thickness is measured to keep within agreed tolerances for writing and printing. Random samples are tested for strength to ensure they don't fall apart in normal use.
Swabs can be cultured to confirm that the cooking and drying steps did their job.
Basic hygiene stations remind staff to wash hands before handling finished goods. Personal protective equipment is provided and encouraged in all high-risk areas.
Regular safety walkthroughs help prevent accidents and keep processes in check.
Many teams track not just output, but also how much water, energy, and waste they save.
By using dung fiber instead of wood pulp, they can help reduce the need for cutting trees.
In some regions, this industry supports local communities and elephant care at the same time.
Some operations share revenue with sanctuaries, directly funding food and veterinary care for the herd.
So the elephants, the workers, and the environment all benefit from this unusual paper story.
Now, when you open a notebook like this, you know exactly where its story began.
For many buyers, that story is part of the fun and part of the reason they choose it.
From grass to elephant, from dung to fiber, from pulp to paper, the loop comes full circle.
What might seem like waste turns out to be a valuable resource in the right hands.
Next time you spot eco-paper in a shop, you might be looking at the work of elephants too.
It's just another object on your desk, but its journey is one of the most unusual in manufacturing.
We've watched that journey from messy piles in a field to clean, finished products on store shelves.
Subscribe to follow more factories, more processes, and more hidden journeys behind everyday things.